Hey there everybody, Mr. Dickin here, and today we're going to be covering how to verify whether or not two functions are in fact inverses of one another. So here we have the main rules in the box, where it's if you have inverse functions, then f of g equals x, and g of f of x also equals x. So what we have right here, I'm putting a box inside of a box, so you know it's important. That is the definition of being inverses. So our first example here, we have two functions. We've got an f and a g function. If you guys need to pause the video at this point to write these down, by all means go for it. I want to know if these are inverses. And to be honest, just by kind of looking at it, I'm seeing that f of x here, we're multiplying by 3 and we're dividing by 2. Or sorry, we're multiplying by 3 and we're adding 2. So the inverse of that should include dividing by 3 and subtracting 2. So it kind of looks like they might be inverses, but I need to verify for sure. So first, let's figure out f of g of x. So for f of g of x, I'm plugging the g function into the f function in place of x. So the f function says 3 times my input plus 2, and into that input, I'm going to put the g function, which was x minus 2 all over 3. Well, at this point, I'm going to notice that the 3's are going to knock each other out, so that's pretty cool. And I'm left with x minus 2 plus 2. Well, those guys will cancel each other out. So yeah, I'm just left with x. So step 1 checks out for that composition. Let's try going the opposite way. Let's do g of f of x. G of f of x. Well, the g function states I'm going to take something, take away 2, and divide that whole mess by 3. The something that I'm putting in there is going to be, oops, I did the wrong function, silly me. Is going to be the f function, which is 3x plus 2. I have the parentheses there just so I know what I'm plugging into. There's really no distribution that I need to take care of, so right now I'm noticing that the 2's are going to cancel out. So now I just have 3x over 3. Well, the 3's cancel, so I'm just left with x. So these two functions are, in fact, inverses, since I can compose one with the other and just simplifies out to be x. Let's see another example here. Ooh, some radical action. I've got the third root, the cubed root of x minus 4 and x to the third power plus 4. If these are inverses, then I should be able to compose one with the other, and they simplify out to just a plain old x, which is also called the identity. So let's set it up just like we did before. For the first one, I'm going to take f of g of x, which means I'm going to take the f function, the third root of something, minus 4, and into that something, I'm going to plug the g function, x to the third plus 4. There's really no distribution I have to take care of. I'm noticing I've got a plus 4 and a minus 4. Those go away. So now it's just the third root of x to the third. Well, the third root of anything to the third is just itself. So essentially, this radical and this exponent would knock each other out. Lo and behold, I'm left with plain old x, which is exactly what we wanted. Let's double check the other way and just make sure. So we're going to take g of f of x. That means I'm going to plug the f function rule into the g function. So the g function states I take something and cube it, and I add 4. The input here is going to be the f function, so the third root of x minus 4. Now, just like we saw at this step, where an exponent and the radical index can kind of knock each other out as long as they match, that's going to behave the same way over here. I've got an exponent of 3 and a radical index of 3. Those would knock each other out. So I'm just left with x minus 4 plus 4. 4's knock each other out, and I'm left with plain old x. So these two functions are, in fact, inverses. Let's go one last and final example. Is this the same one that we just did up above? Nope, it's not. Very similar to the one that we just did up above. So we're going to set up f of g of x. The f function states 3 times something minus 4. We're plugging our g function, which is x plus 3 all over 4, into that. Let's see here. Ooh, this one doesn't cancel out quite as nicely. That's a total bummer. Dang. Well, if I make this prettier, this is going to be 3 times x plus 3 all over 4 minus 4. If I make common denominators and distribute, this will be 3x plus 9 minus 16 all over 4. So essentially, I made this 4 over 1 a 16 over 4. So now I have 3x, let's see, 9 minus 16 minus 7 all over 4. And well, it's looking like that would not simplify out to be just plain old x. So if I composed one with the other here, I would not get plain old x, so those are not inverses.